So we're going to close out the day here with an awesome panel with our favorite buzzword, artificial intelligence, our favorite acronym, AI. We're going to talk a little bit about how to get ourselves off the X, how to make some things real, some more how challenges we might face. We'll go around to the panelists real quick to get a little bit of an introduction, but if you want kind of a who's who of folks who make this happen every day and who actually get things on the net, we have them on this panel. So I will go immediately to my left. Aki, over to you.
Cool. Can you guys hear me all right? Yeah, cool. I'm Aki from Palantir. I serve as president and CTO of our U.S. government business. I've been to the company a little over 18 years and really had the pleasure to build a lot of the original software and then really take the software, bring it to the field, work closely with warfighters to adapt it to their needs and iterate. So really grateful to be here and the opportunity to address that wonderful topic of artificial intelligence.
Hi, good afternoon, everyone. My name is Keegan Mills. Right now, I am the Engineering and Cyber Technology Advisor to the Commander of Marine Corps Systems Command, professional nerd. I spent most of my career as a technologist building an enterprise around emerging technologies, and now we've got AI as the key emerging technology and looking to leverage that for the warfighter and for the business of government.
Hey everybody, I'm Dr. Jack Long. I'm an activated reservist at the Office of Naval Research. For a few years, I was the Deputy Chief AI Officer of the Navy as a part-time role, and when the Chief AI Officer, Brett Vaughn, retired, I was activated full-time on ADOS last June. That's my role.
Excellent. For our AV crew, it's a little hard to hear some of the other panelists, and I'm not that old. I forgot to introduce myself. So I'm your cruise director, just like Julie from the Love Boat without the drugs. My name's Duncan McCaskill. I'm the Chief Data and Analytics Officer for the Department of the Navy. And in my heart, I'm just some guy who likes data. We may, you can judge at the end, have given some questions to the panelists ahead of time. And rather than memorizing them myself and trying to keep on theme, if you will excuse me for looking at the very small device, I assure you we did not use any generative AI to develop these questions. At least I hope we didn't. If we did, great. We'll never know. So, to set some context, we have a lot of hype around artificial intelligence. If you had an opportunity to be up at Don IT East on the first day, Dr. Bill Stryline, who is the CTO for DoD CDAO, how is that for lots of acronyms? Bill kind of asked a question, do you think that AI is the whiz-bang, everything to all people, it's going to solve all our problems, or do you think that it's all hype and it's meaningless and it's just kind of statistics and it's kind of both and? So we want to kind of demystify and ask the questions of ourselves. How do we actually make it real? What infrastructure do we need? What data do we need? So keep in mind that context. Also keep in mind that we have someone who sits in the Secretariat and pushes paper and hasn't coded anything in Python in probably a year. We have someone who is in industry, who does this stuff every day operationally for not only mission types of use cases, but also business types of use cases. We have Marine Corps elements as well, and we have our Office of Naval Research. So we're getting a pretty wide gamut of talent and perspectives on AI. So with that as our context, and avoiding that hype, we were talking a little bit about Stanford and about learning, and some of us have completed graduate school, some of us haven't even completed our comps yet, so we're studying. But one of the first things we want to do is we want to define terms as best we can. And there are a lot of definitions out there. They're getting through that hype. So kind of working definition of how we would term AI. Aki, first to you, how do you approach it, or how do you define artificial intelligence?
Yeah, so Dr. Karp, who actually has a PhD though in philosophy, our CEO, he kind of defined it in a pretty broad way. He just said, look, AI is software that works, right? And there's a little bit of double meaning in the works part. And in particular at the time, he's talking about generative AI. But when you think about it, the point of AI is it's a means to an end. It's a way for you to achieve your work more effectively, to augment your decision making, and to enable you to deal with a lot more data than maybe you could by yourself. That's really the way we think about AI. There are a lot of different implementations of AI, from machine learning and different algorithms that have been developed over a very long period of time where compute has finally caught up and made them real, to more emergent versions. Like, I can't tell you what I think quantum AI is exactly going to look like, but we'll definitely have new properties and abilities to enable you to more effectively do your work. So when we think about AI at Palantir, what we're really thinking about is AI is just a means to an end. It's a way to enable you to do your work at scale and to effectively drive a decision, drive an outcome, drive some kind of analysis that'll then lead to the next kind of step in your process. So we use that very simple approach when we think about AI.
Keegan, over to you.
Yeah, I'm not going to repeat. I agree with everything that he just said. I will add that we think about it, or I think about it, as that subset of artificial narrow intelligence, the ANI piece, that is enabling us to make better decisions faster and better product faster. So one of the government use cases here, I suppose this is applicable to everybody in business too, you're always trying to do more with less. We're always resource constrained. We're always people constrained. What can we give our people to make them more productive, to give them the opportunity to maybe do a little less repetitive, annoying tasking, to get more substance out of their day? Those are the things that I'm looking for on the business side of the case. And then there's a warfighting aspect to it as well. How do I deal with you've heard of the PACE plan. When I get into the contingency and the emergency, what do I do when I don't have comms? The autonomy, the lethal autonomy, that's what I think about when I think AI in that context. So those things that make us better, make us faster, getting after the problem. Over.
So I like to think of AI in a very, very broad terms, right? It's the ability of a machine to solve a task, in particular a synthetic machine. And whether the flavor of AI is machine learning or Bayesian statistics, or older school stuff that was before software came about, and that's broadly what I look at as artificial intelligence. And I kind of look at that, I say the first time an artificial intelligence flew an aircraft, planes were developed in 1903 with the Wright brothers. We had the first man on the moon in 1969. First time an AI flew an aircraft was 1913, right? So that was before software. We used to make machines that didn't work on software. We had other ways of creating intelligence in a machine. And over time, we realized actually software is with the growing power of compute, software is it's easy to work with because you can break out the problem and you can break it out into different sections. So building that logic into it is very easy. So AI is ultimately our ability to build a machine that can solve a task. Whether that task is usually very narrow, over time, the complexity of the task we can solve with a machine has grown. It went from spell check to grammar check to now it's generative AI and actually creates the words for you. And in the middle was actually the auto fill-in of the next couple of words. That's all this incremental growth, and the power of AI is the task it can solve gets more complex because the algorithms and the compute and the data that we work with are all growing. That's how I think about AI.
Excellent. So we have a working definition, or a set of working definitions. So kind of that next step. All right, we've defined it. We kind of have a sense of what we think it is, and then we have to ask ourselves, what is the role of this thing in helping us accomplish our mission and functions? So we'll mix it up a little bit. We'll go to Jack first. Where do you see the role of artificial intelligence in helping naval elements meet their missions and functions? You can get as broad as you want, or you can get as specific as you'd like.
Thanks. I think, again, it goes back to we align AI to solve a task. And I say a task, not a problem, because a problem is very open-ended, whereas a task is very discrete. So when we think about that, where does the power of the computer, or the power of the machines we're using to build this exceed the power of the individual right now? So mathematics, the ability to do calculations around large numbers is something that's very powerful for AI. But the decision making is still narrow. And if you think about, I like to use a decision support tool when it comes to wargaming. At some point we're going to get there. But AI started with tic-tac-toe, and then it was checkers, and then chess, and then Go, and then StarCraft, and then poker. games that we never thought were, and every single time the new one was, before it was solved, people were like, you'll never solve that next version because it requires either too many degrees of freedom, too much bluffing, or something about it, and we figured it out. So that's one application of AI I see as a decision support tool. Likely, and if you've paid attention to what Gary Kasparov is doing, you'll see that it's not that the AI is the best chess player in the world. It is, but a human paired with an AI can beat the best AI chess player any day of the week. So if I'm an admiral or a general or a commander, what's the decision support tool that supports me while I'm fighting a war? And that's one decision support use case.
So I'm looking, data has been a big topic here. I'm looking at the nature of the data that we in the DoD space and in the government space in general deal with, lots and lots of unstructured data. So a very quick win here, applying something that AI is very good at, Gen AI specifically, is being able to answer questions where the answer is distributed across a whole bunch of data sets, some of them structured, some of them unstructured. So while we fight to normalize our data and figure out how to have common data, AI has the potential to make that, I don't want to say irrelevant, but make that problem easier to solve. So if I can have a workforce that spends less of its time searching through mountains of unstructured data to get to elements that are needed to populate a spreadsheet or answer logistics questions, then that is a huge, huge way to boost performance of the workforce and to increase the speed at which we get answers and outpace our competitors.
Yeah, and if I were just to double tap on Jack's point, right? So I think of ultimately, the human and the AI as kind of a team, right? And that teaming, I think, is the critical component. And so when I step back, and I'm by no means a Navy expert, right? I'm okay at software, but I don't pretend to understand the difficulty of decision making in different high pressure situations. I think using it ultimately as a decision support tool, which I have seen in other contexts it be leveraged by folks making critical decisions where lethality is a consideration, I fully agree that it can help. I think there's also this really interesting journey, though, from where we are today to that point, right? Because hopefully we also aren't necessarily in that. The deterrence works, and we don't have to get there. And so that journey of kind of learning and kind of the man, train, equip component of it, and in particular, like what can you be applying AI to now that is enabling better decision making, better readiness, better deterrence immediately, right? And I think unstructured information analysis and processing is one of them. I think the other part, kind of leading a little bit on the Secretary's comments and CNO's comments of, well, hey, look, for the next couple of years, we may not be able to bend nearly enough metal, right, to necessarily fully be at a pace with the enemy. If that's the case, well, how can we use software and data and AI to create some kind of asymmetric advantage? The things America is great at are software and AI. We are world leaders in this. Also happen to have the world's best Navy, right? If you put those two things together and we look at opportunities right now to optimize preparedness, readiness, fleet maintenance, to make it easier for maintainers to do quality control on the line, leveraging basic computer vision, there's so many different opportunities to even apply AI to right now. So just think about places you have humans doing tasks where augmentation would be meaningful, and it can be described as a problem that AI is good at. Computer vision, AI is very good at. Certain forms of generative AI, I think there's, you need a couple of guardrails because sometimes the AI gets confused, right? So you need a couple of guardrails there. Those are the things that we just need to start doing, right? If we do, and we start with the problem and work backwards, we will develop the actual intuition for how to leverage this capability when it most matters in those deep decision support kind of use cases.
That was excellent. Thank you very much. And I love, Keegan said the word data, and we all know I love the word data. I would love to take a data bath with lots of ones and zeros just streaming through my silver locks. But with that being a little bit weird, let's get back on track here. So data is it is a necessary precursor. Is it something that you need in order to leverage to develop, train, test, instantiate models to build AI. And one of the things that we were talking about earlier today, Aki, is when is the data good enough? When can you start? What are some of those challenges? And I know you all have done a lot of excellent work with some of our colleagues in other services that we will not mention because we're allergic to them. But can you talk a little bit about data and AI together? How do we get our data to a good enough place? Where do you begin? Because we sometimes have trouble getting ourselves started.
I actually think it's kind of in the prior point what you just said, getting started. That's like the most important thing. I think they're Seinfeld fans. Anyone? No? Newman? What's the problem with the mail? Never stops, right? And so I thought I'd get a couple more Seinfeld fans. Data never stops, right? And I mean, we've all heard it's kind of trite at this point, right? Like there's so much data, I can't deal with it, and there's only going to be more, right? But we live this every day. Does anybody here actually practice inbox zero? The concept that you actually get to the bottom of your inbox, 2, 3.
Does
Okay.
trying count?
No. Yeah, so my intent is always positive. But so 3 of I don't know how many folks are here have enough discipline to achieve that, and the rest of us have kind of said, "Wow, if it's that important, somebody will call me, or they'll text me, or they'll double tap the email, and then I'll know it's important." And so right now we're applying all these kind of Band-Aids to try to deal with this data deluge. And the trick here is that we'll never be able to study it all enough. We'll never be able to create the perfect ontology or taxonomy for it. So all you have to do is get started. And the other thing that I think is interesting both about software, AI, and data, and just realizing, it's a means to an end. What is the thing you're actually trying to do? You're trying to solve a problem. So you have to start with the problem, work backwards from the problem to the users, the humans who are solving that problem today, from the humans that are solving the problem to the systems that they are using to then pop down to the data. And if you kind of apply that, you pop the stack over and over again and you just that's how you get your way to the data, then what you'll find, and the approach that's worked for us with the tooling that we built is, well, hey, I don't need all the data, I just need this piece of the data that's in that system. And if I just curate that slice of it to answer this question, I don't need to boil the ocean, right? I can actually get after this problem, get down to the data, and then when the next problem comes up that needs a different slice of data from that system or elsewhere, you simply keep kind of driving that innovation flywheel or kind of transformation flywheel to take the data and use it when you need it in the scope of a specific problem. And that will actually get you an incredible data asset. But moreover, you'll get a user base that is leveraging that data to do something different in their work every day. And that's kind of the most important thing.
Oh, excellent. Thank you very much, Aki. Keegan, similar question to you, but maybe a Marine Corps lens and maybe some kind of Marine Corps missions and functions feel, if you would, please.
Yeah, actually, I was gonna essentially say what you just said, but in the context of a military organization. So the question, what is enough data? How do you get to the right? You start with what you have. So we have what we have. We start there. What that does, that will expose the gaps. We will be informed what we need. We have a really strong enterprise about identifying gaps, prioritizing those gaps, applying resources to fix those gaps, and then applying the whole engineering apparatus to solve for those gaps. So we have that in spades. So I say we start with the data that we've got, we identify the gap, and we fix it.
Yep.
Jack, over to you.
Yeah, and I'll speak as a Marine too. To me, the idea that our data is going to be perfect, we're going to get it fully perfect, fully labeled, fully everything, before we start using it was always kind of the wrong way to think about it. The Marine Corps, we don't wait for the supply system for everything to be counted, everything to be folded and neat. You go with what you got. And it's always going to be catching up. That's one of the things you learn in combat is that the supply and logistics system will always be behind. That's just the way it is, and you learn to work that way. To me, when you think about AI and data, you start with the use case. What do I want to do? What's the AI I want to apply, and what data do I need? I think that if you were to think about data that we stored, labeled, housed, but never used for analysis, what was the point of us holding that data, right? Maybe we're going to use it in the future, but you should be, when you're storing data, you should be tying it to a use case. And it could be a future use case. In the future, I expect to use it like this, but I think that you get after the analytics solution. The data is there to support the analytics, and the analytics becomes the AI, not the other way around. That's kind of the way I think if you think about it that way, that's how you think about what solves for what. If you solve AI first, you will naturally solve for the data you need.
So we're going to pivot a little bit. We have this behind us. We have all of our friends and colleagues in industry who have spent a lot of time and a lot of money building products, building things. Sometimes it's software, sometimes it's actual tangible things that you touch, kit that you bring with you. We have the best industrial base in the world, and we have the best industry. We have the best partners. So the question, and kind of following, and you can parse out kind of a similar method here, and we're talking about, we start with a question, we start with a problem. What type of problem are we trying to solve? And we're going to leverage some type of method to solve that problem, and we're going to need data to do it. So there's some friction in there, in some cases, of what method is appropriate, what data is appropriate for which method. That it's not something that I think we individually in government or military can solve ourselves, given the sheer amount of decisions that we have to make every day. So how do we best leverage, and I know you're biased because you got a great product, but how do we best leverage everything that we see here today? How do we best integrate with industry and make those industry partnerships so it is not too much fierce competition, and we have some of our defense industrial base left out in the cold because they didn't win a procurement, but that we're able to leverage all of this excellent work to make us bigger, faster, and stronger. So Jack, starting with you, sir, please.
So much of what you're going to hear from me about this is I'll take the notional or the ideal use case. So when I think about what a solution should look like, I always start with what is perfect in an ideal world with no constraints and no restraints, similar to how we do backwards planning for any kind of project management. So in a perfect world, what I'd like to see is, one, the ability to leverage the best that industry is able to bring in for us to be able to mix and match in different places, right? So if we've got a missile from one vendor, the seeker from a second vendor, to be able to put models on that seeker, and potentially multiple models that work under slightly different conditions from different vendors, and to do it quickly like that. I'd love to be able to integrate that, because that allows us to deploy the best solution while maintaining the competition across the vendor base. And as vendors build different solutions, they can specialize in things. I know that's hard to get to, but that's one of the things I'd start to look at. It kind of gets to the commoditization of a lot of the things we're looking at. In particular, I'd love to see us be able to commoditize the buying of compute. We buy jet fuel in bulk very cheaply, or basically at cost, because it's mostly commoditized. And the oil companies still make a solid profit on that. When you think about how do we commoditize something like compute, that usually means it's kind of one size fits all, or maybe a couple different grades. But if you look at how we do compute, we've got compute at IL2, compute at IL5, compute at IL6. Those are all different flavors of compute, which we have to bucket out. So we lose the ability to get economies of scale. So when I think the perfect solution is our ability to leverage economies of scale and leverage best in class and do it quickly, and the faster we can buy what industry produces, your cash flow, your cash flow from development to revenue is much shorter, and we can support you on that as well. So we have to figure that out.
Faster. Okay. I think the government needs to get better, get better at this idea of commodity hardware and software enabling that hardware to do a specific thing of the day, because that's going to change. We need to accept the fact that we're going to buy things and we don't have to sustain them. They're going to be replaced before they need to be sustained in the future. I don't want to sustain my hyperconverged infrastructure stack 5 years. I want something different in 2. because it's going to be that quick that 2 years from now, that at that price point is going to be so much more powerful than what I can buy today. And that's the process that I think we have to get comfortable with. Now, I don't think we need anything special to do it. It exists today. There are examples of this today. I look at Project Overmatch, for example, and as much as they're delivering to the fleet, I think they're also teaching us how to move faster, how to be agile. So there are pockets. It is happening. It is a culture change. And I'm happy to be a part of it and happy to have those conversations, but I really think it's on us to use what we have and stop complaining about acquisition being slow. Doesn't have to be. We have the tools. We're better than that.
I would plus 100 everything you both said. And I'll throw a little spice into it, just because I promised. Highly biased, right? So like I admit that up front. Like, so I think, look, the first thing is there's a cultural thing, right? And I think the first aspect of the cultural piece, and this was something, I was at the DIU summit yesterday, and Admiral Caparo was kind of addressing kind of what he's trying to do for his command, at Pac Fleet, and kind of one of the things he said was like, look, the biggest thing here is I need to enable the force to be more risk-taking, specifically with data, AI, technology, because everything right now is very much about downside minimization, right? Like, you have a set of things, you've been trained to use them to achieve an outcome, and hey, you're going to go achieve that outcome and that mission with what you have and what you've been given, right? And the ability to take more risk, to push on that, to take advantage of the asymmetric advantages that we have with software, AI, data, systems, take more risk even in the accreditation process, those are really, really important things that culturally we need to break through by taking folks that deliver and calling them out for the great work they've done, even where they've changed the risk aperture a bit, right? And so the first big thing is, the risk kind of acceptance profile, I think, culturally needs to change, and that's hard, right? And he had a much better analogy, and it's publicly, I think, on the DIU website. I think his frame was like, folks in actual battle will take extreme risk. In acquisitions, we will take no risk, right? The same human, right? And so how do we start to rebalance that a little bit was kind of the frame that he used. And that really resonated with me, and I think that's something that's important to think about. I think the other part of this is that I do think the traditional defense industrial base, most of the logos in this room are software companies, at least that I can see. But the really large OEMs, the people that build the incredible, exquisite capability in hardware that can build those incredible long-range weapons and strategic weaponry, are partners, right? We work with almost all of them, right? Because they're also commercial companies that have supply chain issues and have other types of issues and data management issues, just like any of our normal kind of commercial company base. About half our business is commercial and half of it is government. But that defense industrial base and how they're incentivized under the current system is very different than the commercial industrial base and the software industrial base. And so I think a lot of times there's probably like a concern on how are we going to put the right incentives in place in order to really get new defense tech, or even just the general commercial industrial base involved in defense use cases. And we believe at the limit, the entire commercial industrial base will and should be involved in defense, right? Serving some kind of national security purpose. The incentive structure there is really simple. Yes, faster, but it's also just like, where's the money, right? It's just that simple. The market works when it's a commercial industrial base that's large. When you only have 3 people in the world that can actually build you an exquisite capability, you have to create very different incentives for that audience to keep them on the edge of innovation and to keep them, frankly, in business. You got to cash flow them fully. But the money will, the commercial industrial base will follow where the money is. If y'all had a guess, and I'll use three numbers here, what % of the current fiscal year 2024 DoD budget is going to be spent on commercial software? And we'll do, I'll just start with 10%. Anybody? 5%. You got one? All right. Less than 1%. That's the last answer. Yeah, it's far less than 1%. So what are you telling the commercial industrial base who has an asymmetric advantage that you should be leveraging when you spend less than 1% of the DoD budget on commercial software and capabilities. You're probably telling them like, hey guys, like we appreciate you, but we kind of, like you're not our highest priority. We got 99 other problems that we're focused on, right? And so I think that's not something necessarily we can all change in this room, right? But that's something that we really have to think about. What does it look like to take more and more, especially for this period between now and 2027, 2030, depending on when you think we're kind of like in the clear from a mass perspective? What does it take to make sure we're getting all of those companies involved and bringing their solutions to each of you, to other folks in the government, to find advantage, to effectively outpace the adversary? And it means probably putting our money where our mouth is. Again, super biased, but I think that this is something we really need to start to think about and analyze. And funniest part of this, we don't measure this. There is no way for the DoD today to tell you exactly how much money it has spent on commercial software licensing at all. They can tell you they have an ELA or an IDIQ, but they cannot tell you the exact number of dollars. And so when people then say, well, it's really expensive, and so we're going to have to build it and do a developmental, they also can't tell you what the full life cycle cost of the developmental is, because after 5 years, it's you go into a new program. So there's just something there that we have to start measuring it, and we have to actually start putting money behind this problem. And then commercial innovation will stream into the DoD.
I actually have one note. We hear a lot about we have to take more risk. I'll give you the opposite opinion, or at least a naysayer on the sense that I don't think you actually can change a lot of people's risk tolerance. You look at people that seem to take risk, and I don't think they're risk takers. I think they look at risk differently. And I look at it as type 1 and type 2 risk, right? Kind of like there's a risk of doing something, and if I do it, I screw it up. But people that look like they're risk takers actually look more at the risk of not doing something and recognize that not doing something is actually a huge risk. And then you're like, wow, they're actually super risk averse, but they realize that the risk of not doing something is bigger than the risk of doing something, and they did it. I'd actually like us to push more on that and to do a better job of articulating the risk of not doing something. And I think that'll drive a lot of the, not necessarily risk averse, but get people to recognize they're taking more of a risk than they think they are by not doing something, and that should probably drive faster and more aggressiveness.
Yeah, that's a good point.
So I want to jump on that because I'm 1,000%. And if you were here this morning and heard Admiral Paparo speak to us, we have to win the information fight, 100%, right? So we are, I saw this demonstration, and I'm going to tie this back to AI, I promise. We saw this demonstration of AI applied to the Marine Corps planning process. And we watched this thing, that exercise planning that typically takes days to accomplish, happen in seconds and minutes. And if that's what we're up against from a decision advantage standpoint, then we absolutely have to do this. We cannot compete as humans with that, we have to have it. So I was struck by that, tying it into this, and hearing if we are going to achieve the prime directive of the National Defense Strategy, which is deterring this fight from happening at all, we have to be dominant in this space. We have to think about the risk of not doing it as the bigger problem to solve. So if we do our jobs, then history will not know our names. And I was moved by that this morning.
So this is, I love it when the panelists start riffing off of each other. That's absolutely fantastic. And I think what we've heard thus far is that a lot of the problems that we have aren't really technical problems. It's cultural problems, it's acquisition problems, it's changing mindset of our colleagues. The question that I would ask, when you have an instance, or you have a situation that, Aki, I think you described spot on, where our incentive structure and how we operate is not aligned with how we say we need to operate and with what we say that we want to do. And those aren't technical. How do we tackle those types of problems where we need to completely revamp our incentive structure? And what's very interesting to me is even with that small amount of spend on software, look at all of the software and look at the awesome stuff we have. If we actually funded it more and had more of that, we're going to invest, we're going to have quick wins, we're going to pick the winners. Hey, if you don't do something that's great, well, you're not out entirely for the rest, and your company doesn't fall apart. You can now riff on what someone has written, develop new baseline, all that type of stuff. How do we tackle those types of challenges to reinvent that incentive structure?
Yeah. I do have technical challenges if you want them later, but
okay,
because there's a few, I think. But I think it's similar to like the point on data, right? Like you got to start somewhere. And so the interesting thing, and again, I am not a policy expert, so check with ChatGPT what I get wrong here. But at the end of the day, a lot of the authorities actually already exist, right? And that's everything like the DepSecDef's DoD data decrees, right? Something you're very familiar with. That need to be able to share information between systems, and the idea that this is the DoD's data, right? The authorities are there, the policy is there, but then when you go into like, okay, but I built this system is how I define my program, it's how I define, kind of my purpose and my customer base, and so, well, I feel like the data's kind of mine, and you're trying to work with a data owner who's really a data steward, right, in order to actually get that into another system. It can be really hard, right? So I think a lot of the authorities on acquisitions, from an acquisitions perspective, Congress has also granted, right? OTA consortiums are effective at quickly getting technology to the places that it needs to go through a prototyping to production process, right? That works, and so instead of a 5-year cycle, you can do things in a year or two, sometimes quicker in exigent needs, right? So a lot of those things exist. I think the problem that we typically run into is the education part of it. How do I use that? How do I assess the risk properly to recognize the risk of not doing a thing is much greater than the risk of doing the thing? And I think that I would just also take a second to say, like, where we are today compared to 20 years ago or 18 and a half years ago when I joined Palantir, it's like night and day, right? So we should take a moment to say there's been incredible progress. The thing I don't know, right, is does that mean though that we went from like 0.1% of solving the problem to 1%? So it's an order of magnitude and it's pretty incredible. Or did we actually get from 1% to 10 or maybe even further in the progression? And that's kind of the thing we all have to kind of figure out together, vis-a-vis actually educating and applying those authorities to those problems.
So there may or may not be a technology answer to this question. The question of how do you change the incentive structure? How do you get people to go about changing the incentive structure or the incentives that they're getting? And I want to say it's mostly unintended consequences. People don't set out to create bad incentives. It happens because they don't foresee the consequences of the incentives that they set. So if a picture's worth 1,000 words, then how do you show them what the possible outcomes of the incentives that have been created are? In the engineering space, that sounds, or the answer to that looks and sounds a lot like model-based systems engineering with tools that let you run scenarios and show dependencies and how systems of systems interoperate. I don't know how to apply that to policy. I don't know how to apply it. I'm sure there's a way. I mean, if anybody has a digital twin of an organizational structure that can run scenarios and show potential outcomes of a bad policy or a bad set of incentives, I think that's a potential way to get after that problem. But by and large, people don't set out to create bad incentives. It happens just because people were flawed. And exposing those things up front would be a powerful way to change it, to make it not end the way it ends sometimes.
It's interesting you mentioned that too. When I checked into ONR back in 2020, Admiral Hahn, I specifically asked him that. We do research into materials and energy, and we actually do research into humans, right, for SEALs and Marines. And I'm like, who does research into organizations? Or who's the actually one looking at how an organization should be designed to get the outcome you want from that bureaucracy? And nobody. Like he didn't quite get the question, or didn't quite see it as a field. And I'd come from a consulting firm. I've been at McKinsey where we did org design, where we sat down and like, what does the org need to look like to do what it should do? So I've asked that at O&R a few months ago, again, to somebody else, and we still don't really do it.
So did they stick you with the project?
No, not yet. But to me, I see it's a gap,
Yeah,
right?
yeah.
There should be, you can apply science to how you design a bunch of humans that work as a team. NSW does it for very small teams on SEAL teams, right? So Army Special Forces will look at groups of 2 to 10. What are the dynamic and interaction between them? But what does it look like at 10,000? Maybe it's a gap that we're not looking at as a DoD yet. And I also think that when you look at this, the DoD basically does what it's told to do. Ultimately, as much as it looks like it doesn't, people will do what they're told to do. And I look at the department, and from about 1991 on, after post-Cold War, prior to the wall coming down, the department was very good about developing and rolling out technology to meet an adversary gap, right? We had to compete with the Soviets for decades. So we actually got good at that, and we knew that we had to roll out to match them. When the wall came down, we never had an adversary that was anywhere near us. We were so far above the adversary, our calculus became around how much do we want to spend and how much risk do we want to take. And if something came out 3 years late, well, all right, we're only 50 times better than they are instead of 70 times, right? So we've lost the ability to really think about, we have to deploy to meet an adversary capability, even in peacetime, to stay up for deterrence and things like that. We've got so wrapped up in our own metrics around project management and budget and all that, that the metrics aren't there. And I think a recognition that if the acquisition arm and if the others in the department are told, hey, this is the end state, get technology out the door to meet a capability gap, we will do that. But I think that needs to be a very clear message. And that goes back to kind of like, what risk are you willing to accept? I'll accept a cost overrun, or I'll accept a little bit of something else to get it out there 8 months earlier, 12 months earlier, because the most important thing is no longer cost, right? It's actually speed. So I think we have to, when that guidance comes down from the top, we'll do better at this.
Last question before we go to some audience questions, and here's where we have an opportunity to get a little technical. All of us have worked to get AI operational on a network to meet various naval or other DoD or intel missions and functions. So we all probably have our stories of lessons learned and battle scars and things that we might do differently. So can you talk a little bit about, not specifics, of course, given that we have any foreign intel services listening right now? I know you're here. I can smell you. Yes, they're all over the place. So with kind of that question, talk a little bit about some of the challenges that you face, challenges that we can expect to find as we move from kind of our, in many cases, kind of single solutions to trying to get towards doing things, at speed, at scale, instead of little onesie twosies, small teams, to actually do it across the entire Department of the Navy to help Marines and sailors accomplish their missions.
Yeah, I'm happy to. So I'll throw two specific ones out there. One is a software issue to a degree, and one's a hardware issue. So the first one is effectively, for lack, the ATO process, right? And I think there's a lot of movement to change the underlying policies, the risk frameworks, how you can take advantage of like IL6 and some of the other standards that are out there to kind of at least reduce the burden of doing an RMF ATO. But today, the number one inhibitor to getting net new technology into the hands of somebody who can leverage that to do their job better, more effective, more efficiently, or just deal with more data is the ATO process. We've started a program because we spent 20 years to make this easier for us that we call the First Breakfast, also FedStart, which is about taking all the infrastructure that we've deployed, working with DISA, working with GSA FedRAMP, and now making that security boundary a thing in accordance with each of our programs and the government to allow other companies to bring their technology, as long as it meets certain requirements in a bar, to then come into our DevSecOps environment and be deployed within that security context. So what used to take a year, and if you're a small startup, you've got to get your board not just to give you a year of time but probably like $1 million to do that full cycle of work to get an accreditation before you even have a dollar necessarily in contracts, right? This is just so you can try to get the contract. It's very unlikely they're going to say yes. If you can take that down to 3 months and $20,000, all of a sudden the amount of the commercial industrial base that could potentially play and then get access to these problems to again, create even more competition goodness changes drastically. So we've started that program. It's at firstbreakfast.com, I think. You can read about it, and that's kind of the first part. How do we reduce that burden? Again, in line with the existing policy, right? The existing strategy that the DoD has put forth. The second biggest inhibitor, we think, especially as machine learning algorithms and AI really need to effectively run not just in the cloud. I mean, the cloud has drastically changed our business, Nipper, Sipper, and JWix, and but you're not going to have the cloud everywhere. And even in the cloud, right now, and this is a stat I have not confirmed myself, but somebody in a CDO somewhere told me, not this one, that the DoD right now, in the commercial cloud it has only 6% of the GPU capacity that OpenAI has in the first $2 billion data center that Microsoft built for them. The Department of Defense of the United States of America has 6% of the GPU capacity of a private entity, not a huge company like a Google, right, or a Microsoft that have been doing this for years, but a small startup doing incredible work, 6% of the capacity. You can only imagine what the adversary has, right? And they don't really differentiate between government and commercial, right? So the first thing is GPU in the cloud, and the second point is GPU at the edge. And actually recognizing and realizing the amount of work that's going to need to go into the low swap kind of constraint there. In some ways, space is almost better. Like you've got a TX2 on birds that have been up there a couple of years. You can do some basic stuff on it. But right now, we do not have a good enough strategy, in my opinion, for how we're going to make sure there's not just GPU in the cloud at the level that's necessary to support these machine learning and AI kind of approaches, but also to execute in an inferencing context at the edge across all of our hardware. So that's the other part that I think is a technical problem that we really need to have a more comprehensive strategy around.
I'm going to go policy on this one, and there's a thread here. So see if try to follow this. The problems that we need this technology to solve, and the pace at which we need to make decisions, inform us that we need AI and other technologies that fuse data at multiple classification levels at machine speed. So right now, there is no way to do that. I can't have an LLM, for example, that has access to Nipper, Zipper, and JWix all at once, and then fuse that data, and then there is no cross-domain solution that allows that. To me, that is a showstopper, a blocker that prevents us from even developing and fielding a technical solution. That's something that we need to solve, and we need to solve it fast, because the adversary does not respect those boundaries. They don't have those problems to contend with. So their AI is going to be doing that fusion, and they are going to be coming up with actionable information at a much greater pace, at a much greater speed than we are even capable of doing. We can't throw enough humans at that problem. So I think that is a problem that we need to solve, and we're working on it. The whole concept of data-centric architecture and data-centric security that we're experimenting with at the secret, releasable, and below categories is a huge step to proving that we can develop the tools necessary to secure, operate, and defend data, regardless of what the network is or is not doing for us. But right now, we don't have those tools. We don't have tools to secure, operate, defend data. We don't have tools to secure our AI. What do those tools look like? So I'm looking at the room here. I'm looking at industry. What can we do here? How can we? I know this concept is being done for the banking sector specifically. It's out there, but there's nuance to bringing it to the defense use cases, which you're all here, so you understand that. We need to get after that at speed because I think that's going to be a critical enabler for us to develop the kinds of solutions that we need for the 21st century deterrent mission.
Those are both great answers. I'll give a more tactical one. Bugbear I've seen is the ability of the teams we've got trying to deploy solutions with AI. For example, the inability of them to share models. So we've got teams, we got a team using one model, it works very well. Another team would actually love to use that exact model, and our inability to get that model to them for a number of reasons, and I'll talk through a couple. One, lack of visibility across the department, both Dawn and DoD, what actually everybody is using. So to recognize that, oh, that model has been approved, it's being used for that use case, I have the exact same use case, I'd love to use it as well. And then the next piece is like the contracting or whatever the acquisition process that brought that model into the DoD. Sometimes we developed it ourselves, sometimes it's a vendor one. The vendor's like, no, that's either bespoke or you're paying for it for this. I would love the ability, I hate bespoke. Bespoke really annoys me, and I'd love to make more build once, use many times. I'd also like to see us the ability to lease models. What does it look like to use a model for a set period of time?
Yeah.
And then when you look at that, what about flipping on its head GOTS, right? Or that bespoke commercial solution. If a model, some of the stuff we need will be bespoke, but how can we do it in such a way that whoever built it for us can all turn around and sell it somewhere else as well to get an additional return? And I think about Velcro, right? So NASA had somebody develop Velcro. NASA used it, but Velcro got used for all kinds of other goofy stuff as well. So is there a way to leverage that? It's not for every single model, but to turn that on its head from government off the shelf to government to the shelf. And we share the development costs with industry, and then industry is able to get a return because that thing that we built, they can use somewhere else. That's normal in more traditional industries and development, the aviation industry, things like that. We haven't cracked that nut, to my knowledge, when it comes to data science, AI, and software yet. And I'd like to see us do that because that's where I think we'll get some serious returns to scale.
Panelists, thank you very much for answering all of these awesome questions. I'm dead on my feet, but I'm sitting in a chair. So we have about 10 minutes for some audience questions. There's a microphone in the middle of the aisle. So if you have a question, please stand up, identify yourself, name, company, organization, and feel free to sling your arrows, your rocks, your accolades, whatever they may be.
I don't. Yeah.
Questions? Anyone? Don't be shy. Sir.
So, my name is Bert Wagner. I'm with Broadcom, and I'm a data architect.
Can't hear you.
My name is Bert Wagner. I'm with Broadcom, and I'm a data architect. And I'm really kind of fascinated by the thought of doing AI at the edge. Because when you say that, there's a big difference between creating a model on like an edge node, a drone or something, versus running an already created model that you've done in an analytical environment. Why do we think we need to create models on the edge? Why can we not bring the data into a central processing place, go ahead and use a broader analytical tool set centrally, and then deploy out a model once it's been created and only monitor for drift on the edge?
So I think there's, well, in my opinion, there's two pieces, but these guys probably have a better answer than I do. So the first part is I actually think, let's just say 8 out of 10 times, you're always going to be improving something centrally, leveraging the asset of commercial compute and cloud compute at some point. The issue is the time, right? And so I think on the edge, there's two pieces. So one is, if you're afloat, you're in the middle of nowhere, you're MCOM, and you have data scientists on board, and an emergent threat or the adversary has changed what they're doing, their behavior, and you can sense it. Now you need to update an algorithm, or maybe your search space you want to minimize to a particular signature. The ability to do that work, which requires the talent to do it, being aboard, right, without having to phone home and waste those precious bytes that maybe you don't really want to give away your location, is really important. And we've seen use cases of this at the unclass level vis-a-vis the mission in Ukraine, right? And that's a much simpler context on land, which much closer access to cloud compute than if you're on a ship in the middle of the ocean. Is that fair?
Yeah.
Right.
And I'll add from that from an O&R standpoint, if you look at where the puck's going to be going forward and kind of like what is under development from a scientific standpoint, I think one thing we're looking at is kind of the data mesh idea that the data sits where the data was collected. It doesn't get moved back. And what we do is we create a federated model by pushing out pieces of the model to all those different locations where the data is and then refederating that model. Now, it sounds complicated, but this is where you've got some interesting scientists working on that. And that allows us to actually minimize the bandwidth for pushing around, which is something that's critical in a DDoS environment or where we don't want to have a lot of bandwidth. So the older model of let's create a big data lake, move everything to a giant compute facility and do it there and push the models out and then run them on the edge. I think we're looking and we're seeing the development of architectures where you can train the models in different locations and those models can then federate themselves. And that is likely more of what we're going to want to see. And this is something that's probably not DoD specific, but something we're much more interested in than maybe some other organizations that don't have the same limitations of bandwidth problems and adversaries actively trying to screw with us.
The interesting thing about that is actually a really great dual use example. So a lot of the academic kind of hospital centers around the country, because of PHI data and the inability to move that around, yet the need to leverage, especially for rare disease, every instance of clinical information at different academic clinical hospitals to try to actually pursue some form of a cure or a solution so the same exact need, for very different reasons, privacy protective reasons, is actually there as well for the federated development of models.
And that data would never leave what its environment was, so even though the model trained on it does, but so that's one way to train models on data when you actually have those limitations.
I would also say walk around to some of these vendors that are cloud compute oriented and look at their edge devices that they're showing off here and listen to what they're saying about the control plane for those edge devices and what their vision of the future cloud looks like, and how we think of the cloud now as essentially very large centralized compute places, having that kind of compute power but through distributed edge nodes. So that is a lot closer than I thought it was to being real. So it sounds a little science fiction-y, but walking around here today, the CSPs heard us and seems like they found not only a DoD use case for it, but also other use cases for it. So it's progressing a little bit faster than I thought it was going to progress.
And I would add, if you think about the history of computing, this back and forth between central versus edge has been going on since the very first mainframe.
Yeah.
The very first mainframe, you literally had to walk up to it to work, and then bandwidth got a little cheaper, and we could put a dumb terminal somewhere else in the building. And then compute got better, and then you went from the mainframe, you went to PCs, but they weren't networked because bandwidth was more expensive. And then the internet kind of started to work cheaply, so we networked them all together. And then we went back to cloud, and now we've gone back to edge device. We go back and forth, and it's usually a trade-off between the cost of compute and the cost of bandwidth. So where's the better place to do that? And I always give people the example, if you want to know how much of Siri is happening on your phone versus the cloud, put it in airplane mode and ask Siri a question and see what questions Siri can answer from the device versus what has to go to the cloud. So I think that there's some federated model, some model that's going to be a bit of both, and that is what we're going to be looking at in the future.
It's one of the best sets of answers from a panel to a very short question, so well done. Any additional questions from the audience? Yes. We've got time for probably two more if we're short.
I'll keep mine short. Dakota King from Puget Sound Naval Shipyard.
Could you speak into the microphone a little
Sorry,
more closely?
Dakota
Thank
King
you.
from Puget Sound Naval Shipyard. We've talked a lot about high levels of AI models and integrating in between. Do we have people working in a accessible to the masses of the Navy of a unclass, like just a simple LLM to do general tasking? Is there someone working that currently?
So we're limited by department guidance on what can be in an LLM right now, and it's mostly the guidance is about the classification of the information. So open source LLMs, they're open source, great, but you can't put anything other than distro A information into them. There has been both Air Force, Army, development and Navy development of LLMs that are in some instance of being tested, played with, and there's some at the IL6 and IL7 level as well. So we're working to develop that, and if Captain Lugo were here, he'd tell you from Task Force Lima, their target is to somewhere by this year, and by that he'd probably say this summer, but he's gonna get mad at me for being that aggressive, looking to be able to roll out those tools for the department on infrastructure for like IL5, where they're open to all users. And the Army's starting to push a couple out, the Air Force as well, test cases. They've limited the number of users, but that is something Task Force Lima has been very aggressively attacking for that exact reason. They're like, this is a very powerful technology, can benefit a lot of people. We're super worried about the risks, so we're going slowly, but they're hoping to get something out spring, summer time frame.
I would say it's probably going to be a little sooner than that based on some conversations I had with our CDAO colleagues today. I was tracking what Jack was saying, but I had some good news earlier today. So it might be sooner than we think.
So we'll put some words in Captain Lugo's mouth. It's totally going to be tomorrow.
Yeah.
And his job to deliver on that.
Yeah.
So.
Alex is going to be upset.
Lieutenant, yes.
Okay, awesome. Lieutenant Ebenezer Jesse. I'm a judge advocate stationed in D.C., but currently T80 here. Just had a quick question. If you all were advising Congress on, as they think about legislation, you know, sort of what are the things they should be thinking about regarding safe, ethical, and transformative AI, apply to the DoD or even broadly, just really quickly, we'd love to hear from each of the panelists the types of things you'd be advising our lawmakers to think about. Thank you.
Number one, pass a budget.
Touche.
I was just at Congress last week. Senate asked about the hiring authorities. We actually have all the ones we have for both civilian and workforce, both civilian workforce and uniform. We don't have the billets. We don't know what AI tools we're going to deploy, so we actually haven't created the billets and the TOs yet. So we're lacking on that. That's not a Congress problem to solve. If I did say to Congress, I'd say AI is just math. You know, and with the human-machine teaming, I worry less about RAI when it's paired with a human in the loop, because ultimately the responsibility comes to the human. So if the math isn't right, that's what the human's there to catch. If Google Maps tells you to drive into the ocean, like, don't do it. Like, but the human is still there to catch that. So I worry less about a model that might accidentally send you into the ocean every now and then, because there's a human in the loop. And I would say to Congress, like, worry less about the RAI piece as long as that human is still in the loop.
Yeah, sorry, go ahead. Pass the budget. No, so we've spent a bunch of time actually sharing with Congress and Department of Commerce our thoughts on this. I think at the end of the day, there's kind of like maybe three things that are really important. So I think you know, we need to stop giving away America's advantage to the rest of the world for free when it comes to the pace of development, especially in generative AI. Like, America is very much ahead. We are no longer ahead necessarily in computer vision. We kind of ceded that ground, but here we have an advantage, and you have to create some kind of mechanism for those innovations to still be leveraged in a commercial context here in the US, as well as, like, frankly, in a government context, and create some kind of disclosure mechanism there. Like, again, if you look at the power of generative AI and what our adversaries can do with that, plus with different rule sets, could potentially less ethical uses of it, and frankly, they're using things that were developed here. That's kind of the first thing. So we have to think about, like, how do you enable innovation, but be somewhat protective of how we're kind of giving it away in this context, outside of the government and commercial realms. So that's kind of the first thing. The second thing is, I think that the EO has a lot of interesting aspects to it. Could probably be with ChatGPT slimmed down a little bit. But I think that the most important thing about the EO is, one, they ship something, and two, they're open to changing it, right? So I think there has to be this continued campaign of learning vis-a-vis how is this AI being used, what is advantageous, what is not advantageous, where are there risks, and then the EO has to be updated over time to take advantage of whatever the latest and greatest is vis-a-vis AI. And then the third one kind of goes, again, just back to that context, especially in a government kind of use case where human doesn't always have to be in the loop, but human on the loop are related, right, to the thing. It's the human-machine teaming. Again, AI is software that works, right? But AI, at the end of the day, if you were to go all the way to AGI, like artificial generalized intelligence, right? What are you really trying to do? Well, you're trying to mimic a human. turns out we've got hundreds, if not thousands of years of the ability to self-govern, to build policy, to regulate, to have quality assurance, to test, to make sure decisions are being vetted, and mechanisms to monitor human action. Turns out humans are also fallible. They make mistakes. They get things wrong. Sometimes they even lie once in a while, right? So to that degree, how do we start to actually have AI regulate AI, right? And recognize the same way we have humans regulate humans. Are there ways to invest in and recognize that the issue is scale, so you will need AI, right? It can't be humans just regulating AI, but AI to regulate AI as well is kind of the third thing that we've encouraged them to really think about as they're iterating on some of these policies and processes.
Yeah, in all seriousness, I would also say incentivize the market to create the protection mechanisms for these things early. Let's not repeat what happened with the general internet, where we spent decades not really worrying about security. So let's build those things in now.
Thank you.
Thank you. We are at time, folks. Thank you very much for attending our panel. Panelists, Jack, Keegan, Aki, thank you very much.
Yeah, it's fun.